Hello, my name is Mr. Hammond, and today we're going to take a look at relations and functions. We're going to start off with a few definitions. The first definition that we are going to take a look at is that of a relation. A relation is a pairing of input values with output values. Now we're going to go over a little bit more, or a little bit about what input values and output values mean, starting with the domain. A domain is basically just a set of input values, also known as your x values. And then you have your range, which is the set of your output values, also known as your y values. Now, relations can be presented in a few different forms, so we're going to take a look at some of the forms that they can be presented in. That way, when you go to your independent work, you'll know that not only the forms I'm about to show you, but they may be presented in some different forms. So let's take a look at those. Take a look at the first one. This first one we have here, notice that we have the area of A, and we have the area of B. So in the area of A, you have the 1, 3, and 5, and then in the B, you have 2 through 6. A would be considered your input values, whereas B are your output values. So if I were to plug 1 into A, I'm going to get as an output value either 2 or 3. If I were to plug in the input value of 3, I'm going to get an output value of 4, as described by the arrows pointing from left to right. And then for 5, I get a 5 or a 6. So there is one example of a relation. Another example, you could see a table of values. Now in this case we have a horizontal table of values from left to right. It could be a vertical table of values as well. So just so you know that. Now in this case, again, you see the common theme is that you see your input values and your output values. So the input and the output for that first coordinate there is -3, 25. And then over here you have 1, or I'm sorry, -1 and 9, and so on and so forth. So you have your input values, which are your x values. Output values are your y values. So those are, that's another way you'll see relations. Then you may see them written as simply just coordinates, no table of values. So you have, for example, here we have 2, -5. Remember the x always comes before the y, and how you know that is x always comes before y in the alphabet as well. So that's one way to remember that x always comes before y. And then here, 11, -11, you have your input, output. All right, and the last one we're going to look at is just simply a graph. Now we're going to finish up with a graph, but what we're going to look at next is how to determine whether a relation is in fact a function. How to determine whether a relation is a function. So all the items we've looked at so far, they're all relations, but only some of them are going to be functions. So every equation is a relation. So everything we've looked at. Only some relations are functions. So think about it this way. All circles are considered shapes, but not all shapes are circles. All squares are considered shapes, but not all shapes are squares. And then you could look at it in a different way outside of math. All trucks are vehicles, but not all vehicles are trucks. So that's a way to look at relations compared to functions. In a function, every input has one and only one output value. Now if you notice, if we jump back to this first set here, this first one we're looking at, the input values for 1, for the A is 1, but we had 2 output values. So that would not be considered a function because of that. So now let's jump back to where we were. And then the fourth thing we need to know here, for graphs, we can use what's called a vertical line test. A vertical line test makes it very easy for us to determine whether a graph is a function or not. Now what we do need to use, and you probably guessed it, we need to use a vertical line. So we're going to take a vertical line and we're going to run it through each one of these graphs to help us determine if in fact a graph is a function. Now we need to know what we're looking for. What we are looking for is, in order to determine if it is a function, it can only intersect that graph, no matter where we put it on that graph. It can only intersect at one point. If it intersects at 2, 3, or 4 or more points, then it's not a function. It would be a relation, though, remember. So if we run this through this parabola shape that we have here, at any point that or any location I place this vertical line, it's always going to intersect that parabola at one point. So this would be considered a function. So the first one is a function. Now the second one, the parabola that's kind of facing to the right, if I run it through this, notice it intersects at several locations twice. And then if I jump down here to this line, at any point I draw this vertical line, it's always going to intersect at one point. And so this second one that we were looking at is not a function. This third one is a function. And then we jump over to the circle. Notice that it intersects in 2 locations and several places on the circle. So not a function. All right. And then we are going to finish up with this little activity. Now what I would recommend doing is pausing the video at this point and just going through here and determining which ones you think are functions and which ones you think are not functions. And then what we are going to do after you pause the video, then you're going to see it solved. So just kind of go through there and see how you did. If you have any other questions, please let me know. And have a great day.